Hi everyone, welcome to the source tutoring. That's my email in case you have any question concerning I'm about to do or what I've done in the past. In this video, I'll be doing question 2 of calculus May 2012. So it deals about curvature, torsion, and all that section of curvature and torsion. Okay, so we have this our helix is given by this equation here. So we've been asked to number A, question A, we've been asked to compute the unit tangent vector u, and so we're gonna determine u, which we know that u is equals to r dot divided by the magnitude of r. Okay, so we've been asked to determine u and also to show that the curvature k is given by a over a squared plus c, a squared plus c. Okay, so so we're gonna first determine the first derivative of r. So we're gonna have, so we want to determine u now, so we are answering the question. Okay, so dr dt is equals to the derivative of cos t is equals to minus sine t, so we're gonna have minus a sine t. Okay, derivative of sine t is cos t, so we're gonna have a cos t, and then the derivative of c, where c is a constant. Also know that a is a constant. Where c is a constant, the derivative of ct is equals to c. Okay, now we have this here. So okay, we have this equation here. Now we're gonna determine the magnitude of dr dt, and we know that the magnitude of dr dt, the magnitude is the same as ds dt. I explained this when I was doing a quick review on torsion and curvature. So this is one of the things that we were able to figure out. Okay, now dr dt is given by this is our dr dt. Now we need to determine ds dt, and then ds dt is going to be the magnitude of this. So that means you're gonna say this is equals to, so minus a sine t squared, we're gonna have a squared sine squared t. Okay, and then here we're gonna have plus a squared cos squared t, and then plus c squared. Okay, note that if we were to factor out a squared here, we're gonna have sine squared plus cos squared, which we know this two is equals to 1. So that means we have a squared multiplied by 1 plus c. What I'm talking about is this: we're gonna have square root of a squared multiplied by 1 plus c squared. Oh, sorry. So this is the same as the square root of a squared plus c squared. Okay, so that's our u. Okay, so this is not our u, this is our ds dt. Okay, so to find u, we're gonna divide the r dt by this magnitude here. So we're gonna say u is equals to the first derivative of r, which is equals to minus a sine t, okay, a cos t, and c, and then we divide it by this magnitude here, so it's going to be 1 over the square root of a squared plus c squared. Okay, so that is u. Okay, and now because we want to determine k, so we answered the first part of the question that required us to determine u. So this thing here is our u, and now to determine k, we know from previously we know that k is equals to the magnitude of du ds. Okay, this is what k is equal to. So that means we're gonna have to do some little chain rule here, apply chain rule. So know that to find du ds, we're gonna first have to like du ds is equals to du dt, the first derivative of u, and that will be divided by, okay, let me just do this and then we'll work it out, and then du dt divided by ds dt. Okay, so this is what du ds is equal to. Know that if we are to solve this out, we're gonna have du dt, and then flip the fraction, we're gonna get dt over ds, and this one's gonna cancel out, and we're gonna get du over ds. Okay, so this is it, and then so from what we have here, our u, we're gonna take the first derivative of u to have du dt. We know that we already have ds dt. So taking let me just copy you on my new page. Let me just copy you on my new page. Okay, so I said that u is equals to minus a sine t, a cos t, and c. Okay, and this is divided by the square root of a squared plus c squared. Okay, now let's determine du dt. Du dt, remember that a is a constant and c is also a constant, so du dt is equals to 1 over square root of a squared plus c squared, and that will be multiplied by the derivative of sine is a cos, so we're gonna have minus a cos of t, and then the derivative of cos is a minus sine, so you're gonna have minus a sine of t. The derivative of a constant is 0. Okay, now we have this thing here. Okay, know that we can factor out, we can factor out a, so that means we will have a over the square root of a squared plus c squared, and then that is into cos t sine t and 0. Okay, there's a minus here, so let me just put it there. Okay, so we have this. Now let's determine to determine du ds. We want to determine du ds, right? So du ds, we said that du ds is the same as taking du dt, and then we multiply it by the inverse the s dt, the inverse of ds dt. Okay, so that means we're gonna have okay, let me put back my negative sign here. So we're gonna have a, okay, du ds is equals to minus, I mean a into a squared plus c squared, and then this is multiplied by cos t sine t 0, and then multiplied by the inverse of ds dt. Remember we said that ds dt is given as a squared plus c squared. So under the square root, it is under the square root, take note. Okay, so we're gonna have the square root of a squared plus c squared. Okay, note that if you had to multiply these two here, they have the same basis and raised to the power of half, so that means we can multiply them together to give us, and then like working it out, multiplying this by that, you're gonna get a over a squared plus c squared, and this is multiplied by cos t sine of t and 0. Okay, and then k is equals to the magnitude of du ds. Okay, so if you have to take the magnitude of the u ds, note that these are constant, so they're just gonna be as a over a squared plus c squared, and then in here we're gonna have cos squared t plus sine squared t. Okay, and 0. Remember the magnitude, we need to take the square root of that. Okay, so note that we're gonna have okay, there's a minus, there should be a minus here, so when we square that, minus will disappear, right? When we square that, minus will disappear, so we have cos squared t plus sine squared t plus 0 which is 1. Okay, so this term here, everything here is equals to 1, which tells us that k is equals to a over a squared plus c squared. Okay, okay, so we answered we showed that k is equals to this, and okay, what we can just say, you can just say shown. Okay, now the next question wanted us to determine the normal vector from, okay, let me check it out. Yeah, the question B wanted us to determine, to write down the unit normal vector n and find the unit binormal vector b. Okay, so we're gonna find the normal vector. Okay, I don't know if I will be able to cover torsion in this video, but if I don't, I will do it in another video. Okay, so we know that the normal vector, we know that the normal, so this is part B of the question, part B. Okay, we know that the normal vector is given as 1 over k du ds. So this 1 over k du ds. Okay, And then we remember from the previous from part A, we found everything. So in this section we just plug and play. Okay, so we found K to be equal to A over A squared plus C. So that will be the inverse of that. So we're gonna have A squared plus C squared over A, and then that is multiplied by du ds. So our du ds is this thing here. Okay, so we're gonna multiply this by A over A squared plus C squared, and then multiplied by minus cos t minus sin t minus cos t minus sin t and 0. Okay, now note that this will cancel out this and that will cancel out this. Okay, so our normal vector will be given as minus cos of t minus sin of t and 0. Okay, yeah, so that's our normal vector. Then the next thing we've been asked to do is to determine our binormal vector. We know that our binormal vector is given as u cross n. Okay, so I'm gonna do the cross product. The way that I do cross product, I don't know, people tend to say it's different from what everyone does, but just do your the cross product you're used to. Don't drill into this one, because I don't know, it might be complicated for you. So for me it's much easier. Okay, so we said that our u is given as okay, this our u. Okay, so I'm gonna factor out 1 over the square root of a squared plus c squared. I'm gonna factor that out, and then I'm just gonna have this thing here inside my bracket. Okay, so okay, I don't have enough space here. Okay, like I said, b is equals to u cross n. Okay, so let me factor out 1 over the square root of a squared plus c squared. So that is a factor in u, vector u. Okay, a factor in vector u, and then I'm gonna put my entries. So on u we have minus a sin t, a cos t, and c. Okay, so that is minus a sin t, a cos t, and c. Okay, and we cross that with n that we just determined, and we said n was minus cos t minus sin t and 0. Okay, and then b is equals to 1 over the square root of a squared plus c squared. Okay, and that is multiplied by 0 minus sin c, so we're gonna get c sin t. Okay, and then here you're gonna have 0 minus sin, 0, we multiply this by that, so you're gonna have 0 minus cos tc. So remember that we always have a minus here, so multiplying this by that, we're gonna get a positive, but because of a negative on the jth column, so we're gonna have minus c cos t. Okay, and then the last one we're gonna have a squared, excuse me, we're gonna have positive a squared and then plus positive a squared plus cos, oh, I'm saying this, we're gonna have positive sine squared plus cos squared. So okay, let me just factor out a, and then we're gonna have sine squared t plus cos squared t. Okay, so this simplifies to 1 over the square root of a squared plus c squared. Okay, and then that is multiplied by c sine t minus c cos t and a. Note that here we're gonna get 1. Okay, so that is our binomial vector, and then we've been asked to determine the torsion of the, yeah, we've been asked to determine the torsion also. So we know that the torsion is given by, the negative torsion is given by dB ds dot n. Okay, so that means we'll have to determine dB dt, and doing that, having this thing here as our b, determining dB dt will be dB dt is equals to 1 over the square root of c squared plus a squared. Okay, square root of c squared plus a squared, and that is multiplied by c cos t, c sine t. Okay, and 0. Okay, this is that part of the question. So okay, so we have this thing here. Now to determine dB ds, we have to multiply dB dt by the inverse of ds dt. So that means we're gonna have, okay, I want to find my ds dt. Okay, got it. I'm gonna multiply dB dt by the inverse of this thing here. Okay, so it's gonna be factoring out c here. Okay, let me just say dB ds is equals to 1 over the square root of c squared plus a squared, and then this is, I'm factoring out c, and then we have cos t sine t and 0 here, and then we multiply it by the inverse of dB ds dt, which is equals to the 1 over square root of a squared plus c squared. We can multiply this out. We can multiply that out to be to give us something like that is equals to c over a squared plus c squared, and then is multiplied by cos t sine t and 0. Okay, now taking this into account, we now need to determine the torsion. Okay, so torsion, which is negative, is given by this here, c over a squared plus c squared multiplied by cos t sin t 0, and we take the dot product of that with our n, of which it was minus cos t minus sin t and 0. Okay, so this is vector n, and then everything here is dB ds. Okay, it's dB ds, vector n dB ds. Okay, so taking the dot product and factoring out this thing here, remember with the dot product what we get is actually a what, a scalar. So we're gonna, let us have c over a squared plus c squared. Okay, so cos multiplied by cos, we're gonna get negative cos squared t, and then sin multiplied by minus sin, you're gonna have minus sin squared t, and 0 multiplied by 0 is 0. Okay, and then here we can factor out a negative sign to have negative c, and then this 2 will be positive, and we take note that this thing here is equals to 1. Okay, meaning that whatever we have here is multiplied by 1. Okay, so we are remaining with this thing here only. Okay, note that next to torsion we have the negative sign here, and this fraction here of ours also has a negative, meaning that you can multiply both sides by -1 to get torsion being equals to c over a squared plus c squared. Okay, so this is it, and then you can just say shown. So that was question 2 of May 2012, which was about torsion, curvature, and all that is related to them. Okay, thank you for watching. Enjoy your studies and good luck.